Okay, let's take a look at this problem. We got f of x is equal to square root of x, and from a equals 1 to b is equal to 4. And we want six rectangles to 3 decimal places. 6 rectangles. Okay, they tell us to use this as our pattern. Okay, so this is going from 1 to 2 by 5 rectangles. It looks like what we need to do first is calculate delta x. Although they don't give the formula here, the formula is b minus a, your larger value minus your smaller value, over, and you see it's got a 5 here. This is our number of rectangles. Let's say number of rectangles. So we're going to have 4 minus 1 over 6. 4 minus 1 is 3 over 6, which gives us 1/2. Or, if you prefer to work with decimals, 0.5. Okay, so that's our delta x. So now, it says along the x-axis beginning at x equals 0, we mark successive points with spacing given delta x. They tell us delta x is 0.2. So it went from 1 to 1.2 to 1.4. It keeps adding 0.2 over and over. So in our case, our first one was 1. And remember I said that we could work with, if we don't like fractions, we could work with decimals, 0.5. So the next one would be 1.5, 2, 2.5, 3, 3.5, 4. Now, if you look at what happens here, the rectangle is starting here, ending here. So ours will start here, end here. Actually, let me draw this halfway decent. If we're trying to graph y is equal to square root of x, well, 0, 0 would be one of them. If I put 1 in, that'd be 1, 1. If I put 4 in, square root of 4 is 2, so it'd look like this. Okay, so we're looking from 1 to 4 specifically. So notice when they draw the rectangles here, they have them below the graph. Specifically, above each of the resulting subregions, we draw a rectangle whose height is the height of the curve at the left-hand edge of that rectangle. So come here, left hand, like that, left hand, left hand, the left hand from top is touching the graph. Same thing here, here, and here. Those should be the equal, same width, by the way. Obviously, I can't draw it very well. Okay. Now down here then, it says the sum of the areas of the 5 rectangles, height times base for each rectangle, is given by this right here. Now you might say, well, 1 squared, where's that come from? Where's 1.2 squared, 1.4 squared? Well, if we said this graph is y is equal to x squared, or in our case, y is equal to square root of x, what they're doing is they're taking each one of these values here and they're plugging in for x for the x squared. So in our case, this one would be square root of 1, or 1. This one would be square root of 1.5. This one would be square root of 2, square root of 2.5, square root of 3, square root of 3.5, square root of 4, which is equal to 2. Now that's these values right here. And that corresponds to our height. So we're taking our height times our base. Now notice how all these bases have the same width, because all these rectangles should be the same width-wise. In our case, our width is 0.5. So, applying to this formula, this is going to give us the area. So I'm going to take area is equal to this height, 1, times, now, notice how this starts at 1, doesn't it? Then 1.2, 1.4, 1.6, 1.8, and it's missing something. There's no 2, because we're analyzing the left-hand side. And so when we get to the rectangle here, the left-hand side is 1.8. That's why we never reach the 2. So when we set this up, we're not going to use the 4. Okay, so this height here, the 1, times the, or this height here, the 1 times the width. So we're going to have 1 times 0.5 plus the width for this one right here is square root of 1.5 times my width, which is 0.5, plus the square root of 2 times 0.5 plus square root of 2.5 times 0.5 plus the square root of 3 times 0.5 plus square root of 3.5 times 0.5. Okay, now if I plug that in my calculator. Okay, I got 1 times 0.5 plus 1 point, or square root of 1.5 times 0.5 plus square root of 2 times 2 times 0.5 plus square root of 2.5 times 0.5 plus square root of 3 times 0.5 plus square root of 3.5 times 0.5. 4.411. And that's where they get this 4.411 at. Now it says find the exact area under the curve from A to B by evaluating an appropriate definite integral using the fundamental theorem. Now what in the world does that mean? Well, if we do the integration from 1 to 4, and this is the square root of x dx. So from 1 to 4, and that's x to the 1/2 power dx. So I'm going to add 1 to my power and divide by my new power. From 1 to 4, that gives me x to the 3/2 over 3/2. 1 to 4. Now I can single fraction down here, I can flip it and multiply it times the top. So that gives us 2/3 x to the 3/2 from 1 to 4. I can take 2/3 and put it out in front. And then if I plug in these values, I'm going to have 4 to the 3/2 minus 1 to the 3/2. If I put these back in the radical form, this would be the square root of 4 to the 3rd power. Power on top here goes on the outside. The 2 I can put as my index. That's the square root. Same thing here, minus the square root of 1 to the 3rd power. So I got 2/3 Square root of 4 is 2, 2 to the third is 8, minus square root of 1 is 1, 1 to the third is 1. 8 minus 1 is 7, times 2 is 14, so I got 14 over 3. And that's where this 14 over 3 comes from.